Good day, class. Today we're going to be going over notes on functions, and we're going to be studying particularly with functions and also inverses and one-on-one. So there'll be three topics we're going to be covering. Now, as far as one-on-one functions, you're going to go ahead and have to memorize this. An equation in which exactly and each x value is paired with exactly one y value, and each y value is paired exactly with one x value. Now, what does that mean? It's probably best put to show you that it has to pass a vertical and a horizontal line test. So you also have to memorize this, that in order to determine if it matches the one-to-one requirement that we're looking for, that a one-to-one function must pass a horizontal and vertical line test. So there's two that it has to pass. The horizontal line test, every horizontal line intersects the graph at exactly at most at one point. And the same goes true for the vertical line test, and where that every line intersects exactly at one point. So now let's go ahead, and you may want to have to, if you want, you could pause the video on these other two and write this down. And the reason why I would like for you to write them is because writing this will help you memorize. So we'll be writing this here. Okay, great. Now let's go ahead and actually go into the practice of this. How do you determine if this is one-to-one? Well, the best thing to do is go ahead and graph them and do both a vertical and horizontal line test. Now I know just because this is a quadratic that it's probably not going to pass the horizontal line test. Because if you look at you know how it's a U-shaped graph? And a U-shaped graph will not have that. Now let's go ahead and type our function in. Let's clear our calculator, go to y equals, clear this, and let me look what the function was. Function was x squared plus 3x minus 2. So x squared plus 3x minus 2. So if I hit graph, I'll be here. And so when I apply the vertical line test, it passes in flying colors about everywhere. So when you're looking at this, you're looking at vertical good, vertical good, vertical good. I could go through everything and it'll be good. But the horizontal line test is where it fails. Fail. Fails horizontal line test. And the reason being is because it doesn't meet both conditions that every x must be paired exactly with one y and one y is paired exactly with one x. So it fails exactly the other one, where one y should be paired exactly with one x. So that one here shows you a failure of that. Now let's go ahead and now what should you probably put on your notes is that graph. Go ahead and graph that on there. And what I mean is that when you graph let's graph the other one, so we won't have to be switching back and forth, and we'll put graphs on there. But let me go ahead and show you the other one. The other one was x cubed minus 3. Let's graph that real quick. Let me get back to actually be able to type x squared or x cubed minus 3. Minus 3. All right. Now when I hit graph on that, you'll have a graph, and this one does pass the vertical and horizontal line test because no matter everywhere you go, you're okay. And when you apply the horizontal line test on this one, same thing. We're good. We're good in all features. So we're good as far as horizontal and vertical line tests on this. So I'm going to go ahead and clear this. And let's go back to what we're going to place in our graphs to at least have notes for us. Now with this one, you could go ahead and draw a line and then draw a failure. Oh, actually, you know what? I probably want to do that in a different color. And draw a point here, and says, let me just write down, fails horizontal line test. And for the cube function, I'm going to draw a little X there. Oops, make sure that does not look like a nice cube there, actually, because it should be shifting off that way. Let's go ahead and just say passes. Horizontal line test, vertical line test. Passes both. This one does pass, so horizontal line test passes, vertical line test it does not. Does not pass the horizontal line test. So it's not one-to-one. So we're probably going to write that down. Not one-to-one. And this one is one-to-one. So this one is it's in a different color. No. Yes. Nope. This one is yes, yes, and yes. We're good. Alright, fantastic. Now let's go ahead and move on to the next part of this, which is going to be now to find inverses. Now that we've gone over this part. And go ahead and write this down. Pause the video while you write this down because it'll help you in memorizing. Make up an equation for an f of x that's not similar to the example provided. Determine if you want to make key action. This is create a problem. Create one for yourself and let's make a determination. Everybody should have something different, so what I would suggest is go ahead and try this and then after see what you come up with. Now, and you have to make the determination for all three. Okay, great. Now let's go ahead and move forward. Now let's go ahead and find it. Let's go into inverses of functions. Now as far as an inverse of function, there's going to be a certain step process you're going to have to take in order for us to do inverse. And write all this down. Pause the video as you write this down. But I want you to go ahead and replace the f of x with a y. Switch the place of the x and y's in your equation. You solve for y, and you replace the y with f inverse x, because that's literally what it becomes. So let's go ahead and try some examples. And well, write this down. This is going to be important to know as well, because we're going to, in every one that we work out, you have to also write down the domain and range. So like in this case, it says that the domain of f of x is the range of what we had before, and the range of f of x is the domain of our inverse. So it kind of switches roles in our case. So when we figure this out, we're going to be looking at the domain to figure out the range, and we're going to be looking at the domain of f of x to figure out the range for the other one. So let's go ahead and write, let's go ahead and take our original ones and do what we got to do. So let me go ahead and do this for a quick second. Okay, great. Now let me go ahead and have you write something down, because one of the things I want to make sure y'all understand about this concept is the idea that when we find the domain and range of original function, which we'll be doing, because you don't like that color on there, let me go ahead and switch that out. Let me put black. Undo that. And now this is one of the things I want you to be able to do. I want you to be able to find the domain. First of all, I want you to find the domain and the range of original function. And the reason why is that it makes our life easier as far as doing the inverse, because see, this is really the range of our inverse function, and this is really the domain of it. So with that in mind, it basically makes our job simpler when we're doing these problems, because when I find the domain and range of the next problem of original function, I will go ahead and do I'll just go ahead and kind of just switch the position when I'm writing down domain and range. So let me go ahead and go through an example of what I'm talking about. But let's go ahead and still write this idea. Let's have you, well, you should have it on your paper, but I'll have it up here so it could be kind of like a reminder to us. A reminder to us as far as what we're doing. F of x, domain, and range is really f inverse of x, range, and domain. As long as you write that down when you're doing inverses, it's going to help you tremendously in understanding what is the inverse. So like with this one, before I even begin the problem, I'll know that domain and range is all real numbers for both, which means that in my answer at the very end, you know how we have to state domain and range for these? It's going to be all real numbers, because it's the same thing, and range is all real numbers. But in essence, what I did is I just reversed the order of them as far as what meant what with the other. And it'll be clearer, this concept, on the next one, because we're going to do the same thing. But before I even do anything else, there's already my answer for my domain and range for the next one. So now with this, let's go ahead and replace a couple of things. Remember how we said with this, when you do an inverses, you're replacing the x and the y's? You're basically going to have this. X is equal to, actually, let me change the color on that. Oh, let's make it red. Let's do x is equal to 2y plus 3. So let's go ahead and solve for y, which means I'm going to minus 3, minus 3. When I solve for y, I'm isolating this y. That's really what I'm doing. That cancels. This becomes x minus 3 is equal to 2y. Divide by 2, divide by 2. Which means that now, the answer becomes this. F of negative x. Actually, let me change the color so you can make sure we make an accentuation that now we have physically f of negative x, x, the inverse of x, is really 1/2 x minus 3/2. Now, domain and range has already been found, but that's the inverse of it. So, let's use the same idea with the next one, because I know that for some of y'all, we'll go ahead and you might have some difficulty with this. So with this one, let's go ahead and do this one right away. And let's figure out what the domain and range of this one is. Now when I looked at the domain, now the domain on this one will be all real numbers of x such that x is everything greater than 0, right? That's really what it's saying. Now the range of this function, this is really quadratic. Let me show you with the calculator. This is really a quadratic. Well, actually, I won't have to show you with the calculator. Where, more in a sense, this function looks like this. And where this is 3, so that means that, not because of our domain restriction, nothing exists over here. But with this, it's really saying that our range is going to be everything y greater than 3. Okay. Greater than or equal to 3. Now, before I even begin the problem, well, actually, I'll put it way down over here. Okay, I'm going to take that, and I'm just going to reverse it. So in this case, our domain for my answer is going to be x such that x is greater than or equal to 3. Y'all see what I did? Kind of like, you know how when we do inverses, we reverse the x's and the y's? You're doing the same thing here. All I did is take this and place it here, and take domain and just change the x's to y's. Y is y greater than or equal to 0. So here you go. That's going to be my domain and range for my answer at the end. So all I have to do now is reverse the order of this one. So I'm going to make this x and change the color so it could be a little bit better. We know that there's been a change, y squared plus 3. So now we solve for this. Minus 3, minus 3. This cancels. This becomes x minus 3 is equal to y squared. We take the square root on both sides. I find out that in this case my f of, well actually, my inverse of x is really the square root of x minus 3. And the nice thing about this is I already have my domain and range that goes with it. So here's my domain and range, just like I had said before. So that's one of the things you want to keep in mind when you work on these is first of all, find domain and range, reverse the order, and start working on the problem. And I think it becomes easier for you to get a right solution and answer. Now let's go ahead and continue with this. Now let's go ahead and find the inverses, determine the domain and range. So again, let's go ahead and get the domain and range on this one. Now domain on this one will be x such that x cannot equal 3. The range on this, let's see, probably the best thing to do to figure out the range on this, maybe just to go ahead and get the, look at the graph. The graph might be a good idea to do on this one. So I'm going to pull up my calculator, see if that's a, go with, ooh, so writing, not writing, let's go ahead and do is equal. Look at this. It's going to 5x plus divided by x plus 3. So 5x divided by x plus 3. So let me hit the graph. Let's see how that looks. Okay. So now with this one, it's pretty evident that there is going to be a break in a range, and it's going to be, I would imagine it's going to be at 5, it looks like. And let's see if that holds true. Let me look at the table, see if my table helps me with that answer as far as that it's not 5. But I may even want to zoom out on this one, change my window a bit. Let's see. Let's go ahead and see if that that makes the determination. That, or we always could find it as well. If you're having a hard time there, you always could find it looking the other way around. Because remember how we stated in our function that the let's write this again. Please memorize this right here because this will help you greatly. That domain, and in my original function, my domain is really my range, and that this holds true either way. So, and then my range is really my domain. So that means that if I find the domain in the finished product too, it should probably say the same thing as far as, so right here, before I go ahead and probably state in the problem that I know that for sure my range is going to be y such that y cannot equal 3. So the only thing that I'm kind of unsure of, I think it's 5 is my range, but we'll make a determination for sure when I find the domain of my inverse. So really what I'm trying to say is that once I find the inverse of this one, of this function, I'm going to look for the domain, and then that should tell me for certain if my intuition is right. Now, let's go ahead and solve for this. Now this one, I'm going to do the reverse of it as far as switching the x's and the y's. So I'm going to have x here, 5y, and y plus 3. Okay. Now one of the things I'm going to do is I want to get rid of the denominator in this one, so I'm going to do y plus 3 here, and y plus 3 here. I'm multiplying, because this is division, so when you're solving, cancels that out, and then I'm going to distribute this part. So I end up with xy plus 3x is equal to 5y. Okay, excellent. Now, in this case, I want to get x's on one side and y's on the other. So let me go ahead and now, oh, is that 3x? I think that is a 3x. One of the things I'm going to do is let me go ahead, now that I have 5y over there, let me go ahead and see, this is the only thing that's, I have x's here the way I want them, but I have a y in there. So I'm going to move this y over here and isolate it. So I'm going to subtract xy, subtract xy, this cancels, and I'll be left with 3x is equal to 5y minus xy. And this is where it becomes more clear how to solve this, because see, I'm going to factor out this y. This y is what they have in common. I'm going to factor that out. I'm going to go ahead and move this down a bit, send the page, and I'll go ahead and make this 3x is equal to 5 minus x y. Now you see how my y is isolated? The only thing I have to do is remove this 5 minus x, and I can do that pretty simply by dividing that on both sides, and that will cancel this, and I'll be left with this. 3x is equal to 5 minus x is equal to f, the inverse of x. Now, let's now remember how we said that we're going to look at the domain of this function. Now, the domain of this function is going to be the domain of my original, basically. So, actually, the domain will be the range. I'm sorry, the other way around. The domain, the actual restriction on this, let me make sure I got that all right. So I can tell you for certain that's exactly what we're doing. Let's see. Let me go ahead and pause the video for a second. I want to make sure that I'm doing everything up. Okay, great. Now that you're back with me, let me go ahead and share with you really what we're trying to figure out here. Okay, which is this part right here. Okay, now the domain on this one, okay, which we know that this one cannot, domain on this one when I write it, okay, it's going to be the range of my original function. So that means that domain on this one is x such that x cannot equal, in this case, 5, right? So if that's the case, my suspicion was correct. Now this is what that piece of information will detail, and this is not going to be part of your answer at all. Well, it will be, but in a different way. Because, okay, the only thing that we had missing in our domain and range on this one was just this, what the domain was going to be here. Now the domain on that is really the range of this one. So that means that the range of this one was verified with this one, which x cannot equal 5. Well, and actually this should be -3. So let's make that correction. So that means that in my case now, remember how I said we reverse them? That means that my domain on this one means that x, actually this should be all y's too. Let me go ahead and erase all that. I should have written that with y's because we're talking about a range. So let's fix that. Y's such as y can equal, on the domain on this, that means that taking that order, x cannot equal 5, and I was given my domain and range for sure on this one. But I had to kind of go back to this one and verify, because sometimes it's not always easily seen as you saw in the graph. So that means that my answer is this and this here, as far as when I did this. Okay, great. All right, now let's go ahead and do another example. And actually what I want you to do is I want you to create a problem. So I want you to create a function, and you cannot use an equation you already have used in another problem. Find the inverse of your function and define the domain and range, and make a key for this problem. So go ahead and work on that, and I'll call on somebody randomly to show me their work. Okay. Now that we've done that, let's go ahead and actually move on to this. We're going to verify that two functions are inverses algebraically. And the way we do this is we're going to take some techniques that we used from yesterday's notes, which is composition of functions. And if you didn't understand that well, I do also have a video, and or you can see some of the written notes on there. But we're going to compose the functions in both ways. We're going to do f of g of x and g of f of x. And the results should give you back an x, since the inverse of f of x is x in the domain, and f of the inverse of x is x in the domain of f of -1 of the inverse of the function. So we should be going back, we should be getting an x. In all sense, if we get an x, that means that it is 1-to-1. It is an inverse of each other. So let's go ahead and do this one. Now the first thing we're going to do is we're going to do both. We're going to verify two things here. We're going to take f of -1. We're going to do this composition. And we're going to do the other way around too. So let's start with this one. Now what does this mean? That means I'm going to take this value and substitute it right in here. So I'm going to take 2 1/2 x minus 3/2 and add 3. So it means I'm going to distribute the 2 into 2, and that comes out 2 times 1/2 of x. 2 times that is minus 3 plus 3. And lastly, these cancel, so it means I have x, so yes, it meets that one. Now we're going to do the other order. So with that, let me erase this here. I don't want to, we're going to do the other way around now, in which we're going to take the, I actually probably want to erase all this right here. You'll write on your notes. You have more space than I do. But now we're going to do the other way around, which is now we're going to take the f of negative inverse of x and substitute the f of x in there. So which means we're going to take this and place it right in here. So here, this is what we'll end up with. We'll end up with 1/2 2x plus 3 minus 3/2. So with that, I'll do the same thing. I'm going to distribute here and here, which means 2 times this is x, this plus 3/2 minus 3/2. Those cancel, end up with an x, so yes, that way. So because I did it both ways, I have verified that they're inverses. So yes, so once you show both sides, then that's how you verify that. Okay, great. Now let's go ahead and have you create a problem, same thing, to verify two different functions. So in order to do this, I want you using two equations from your last created problem, verify that they're inverses from each other. And I want to see a key for this. So I'll go ahead and give you some time, and I'll call on somebody randomly. Now that we've gone through that, and I've called somebody randomly, let me go ahead and we're going to do the last one. We're going to verify two functions are inverses graphically. And the way you do this is you graph the f of x, and you graph the inverse of it, and it must be symmetric with respect to the line y equals x. And what does this mean? Probably the best thing to do is show you graphically what I'm talking about, being symmetric. Now what I'm going to do in this case, I'm going to take something that's kind of a little bit simpler for you, and let's take the function x cubed. I think x cubed would be a good one. Let's see, one of them, okay, we have this. We have the cube root of x, or not that. How do we put it? Use a cube root function. That's the one I had in mind. Not cube root, the cube function. Let's say that correctly. Now that that came out in the way I wanted to say it, I'm going to use this, and we're going to find they should be inverses of each other. So the inverse of this one should be pretty simple to find, because once we do the process of solving for y and getting the inverse of this, we'll find out that this inverse of this one is really, so f of negative x on this one is cube root of x, and then the f of x of the original one is actually x cubed, right? So let me graph both of those, and you'll see this symmetric on the line y equal x, because remember that line y equal x is going to graph all three, and we'll show the symmetry on it. So let's go ahead and do that. Oh, it's right. Hold on. Clear. Go back to there. Y equals. Let's go ahead and first of all, we're going to graph the x function, because that's the one we're comparing it to. And then after that, I'll graph the x cubed function. And lastly, I'm going to graph the cube root function that's graphed in such a manner where you make it 1 divided by 3, close parentheses, like that. Let's hit graph. And here's first of all what I'm comparing it to. There's my x cubed function. And there you go. Now if you notice, both lines are symmetrical to the y equals x. And that's how you tell that it's inverses of each other graphically, if you can do the graphic method. Okay, and I think that was it for this one. So let me make sure that I've covered everything I needed with y'all. And there's nothing else. Yes, I've covered everything. So I do appreciate y'all watching this and putting the extra effort. And good luck, best of luck to you.